Hi guys. In this video I am going to talk about the concept of potential energy. Right? Now this is one topic which is relevant for in multiple areas in physics. We'll talk about gravitational potential energy, we'll talk about electrical potential energy, spring potential energy and so on. Right? And along with potential energy you'll also hear this word potential. Right? Gravitational potential, electric potential, right? So as an example, in our houses we have power supply for electric current, and there it will say 220 volts. What is that? That is the potential difference. So again this word potential comes up, right? So I think it's extremely important that we develop a solid foundation and also develop both an intuition of the concept and also the mathematics behind it, right? So in this video I'm trying to give you my goal is to give you the foundational concepts of potential energy. Now, before I get to potential energy, let me start with a more basic concept, which is the concept of work done. Right? So just a very quick recap. So what is work done? So work done, right? Work is done by a force. So as an example, if there is an object here, if I give it a push, right, and my push causes the object to move, then we say that there is work done. Right? So there are two things. So one is there has to be a force, right, and second, the force should cause a displacement. Right? When these two things happen, then we'll say that there is some work done. Work done by what? Work done by a force. Right? So work done is always work. When we say work done, we always mean work done by a force. If there are multiple forces, then each force is doing some work, and total work done is the sum of all the forces. Right? So this is not a recap of work energy chapter, but I'm just trying to give you some elementary ideas. Right? So work done is defined as integral F dot ds, right, where ds refers to an elementary a small displacement, right, and F is the force applied. Right? Okay, so now this is my definition of work done. Now let us think about a scenario. So let us say I take an object in my hand, right? So let's say I have a pen and I raise the pen from here to here. Okay, once again I have an object and I raise it from a given point to a higher point. Now, when the object goes from a given point to a higher point, if I release, what happens? Right? The object falls, right? And when it falls, it gains velocity and it gains kinetic energy, and then it reaches the particular point from where I started lifting, right? When it goes back there, it will have some kinetic energy, right? Which means it's moving. And because it has got kinetic energy, it can do some work. How can it do work? It can hit some other object and cause a displacement. Once again, when the object is falling, it can hit another object, right, or some other body, and it can apply a force and cause a displacement. So when you apply a force, cause a displacement, it can do work, right? So this is the idea behind the work energy, the equivalence, right? So I can say this, that if I take an object, right, and I lift, let us say from point A to point B, right, and this is my new position, right, then when I'm lifting, I'm doing some work, and if I leave it, this object comes back and it can do the work. How much work will it do? In the process of lifting, if I did work W, right? In the process of lifting, if I did work W, when it comes back, it will do the same amount of work. And this I'm talking specifically for gravity. So this is for gravity. Okay, for gravity, the work done, I do W work, I take it from here and then I leave it here, right? And then if I leave my hand, it will come back and do the same amount of work. Okay, so this is first observation, right? First observation is work done by me, right? Work done by me, right, is equal to W. And second, when I release, right, upon release, right, the object can do W amount of work. Okay, so now I could argue that look, when I lifted this object from point A to B, let me call this A and this point is B, right? I lifted from A to B, right? When it comes back, so I do some work and then I get the work back. Once again, I do some work, right? And then when it comes back, it can do the same amount of work, right? So what does it look like to you? So it looks like the work I did kind of got stored somewhere, right? Just like, going to a bank and you put like, say 10,000, rupees or dollars or whatever, and then someday you go and get your 10,000 rupees back, or 10,000 reals back, or 10,000 dollars back, right? So it's like putting money in a bank and getting it back. So there I can say that the money is stored in the bank, and you put it there, you deposit and you get it back. So similarly, one could argue that it looks like this energy is getting stored, right? The work I did got stored as energy, and I'm getting it back, right? So this is what so I can say that there is some energy stored, and I'll give it a name. I'll call it the potential energy, right? So third point is work done, right? Work done, right? By external force here, right? I can say it got stored, right? It got stored as some energy, and this I'm going to give it a name. I'll call it potential energy. Potential energy. Okay, and when it comes back, that I can say that when I did the work, it created potential energy, and then it comes back, and that potential energy gets converted into kinetic energy, right? So when the object, so here the object has potential energy, right? Here the object has got potential energy, and when it comes back, right, it will have some kinetic energy, right? So I can say that potential energy is getting converted into kinetic energy, right? And here I'm talking about gravity. So this potential energy is specifically, to be more precise, I should say this is gravitational potential energy. So this is gravitational, right? Gravitational potential energy. Now next point, right? By the way, I'm going to make a lot of these, I'm making an argument by making it step by step, so you have to make sure you follow every single thing, right? Next point is that I did some work, right? Now we go back to your work energy theorem, right? What does the work energy theorem say? It says work done is equal to change in kinetic energy, right? If you are not clear, you have to go and verify this, right? So you have to be clear about that. So I'll write this here. So work done is equal to change in kinetic energy, right? Now when I take this object, okay, I take this object from point A to point B, right? Look at this carefully. I start from point A, it's at rest, okay, and I take it from here to here, right? Or I could also, okay, let's take this case first, right? So I start from rest and it goes to rest, right? So what is the change in kinetic energy? Zero, right? Because initial kinetic energy was same as final kinetic energy. Or I can say object is moving slowly and it moves with this. So starting from this point, it's moving at the same speed and speed doesn't change. In which case again, the initial kinetic energy and final kinetic energy is going to be zero. So here, what is my delta kinetic energy? Zero. So what is my work done? Work done is also zero, right? Total, but this is total work done. But I did some work. I just did this work W. So how is the work done zero? The work done is zero because when this object went from here to here, I'll use a different color, right? I'm applying a force. The external force is in upward direction, and the work done by me is, so force in this direction and the displacement is in this direction, right? So both are in same direction. So work done by me, W, is positive, right? This W, this is positive, right? This is the work done by me. What about the force of gravity here? The force of gravity is in downward direction. Gravity is pulling it down. Now what is the work done by gravity? The force is downwards. I'll go carefully here, okay? You just make sure you understand this. Gravity is pulling it down, but the object is moving up. So the work done by gravity, is it positive or negative? It is negative, right? Now what's the total work done? Total work done here, right? We'll say total work done, W total is equal to work done by gravity, right? And plus work done by external force. External force is myself, okay? Now work done by external force is given as W, and total work done is equal to 0. Why? Because total work done is equal to change in kinetic energy, which is 0. The body goes from rest to rest or from same velocity to same velocity, right? So we know that this is equal to 0. So this is equal to work done by gravity, right, plus work done by external force, and therefore work done by gravity, right, gravity is equal to minus of work done by external force, and you just use W for that for now. So this is going to be W. Okay. So now point number 4, right? Point number 4, the potential energy, right, This is equal to W, but this is also equal to minus work done by gravity. This is a very, very, very important point, right? So now let's rethink what I said. So I said that I was doing some work, right? I was doing some work, and when I release, I'm getting the same work back, right? Now, since my work is negative of work done by gravity, another way of saying this is, okay? Listen carefully. Don't make sure that you don't get this wrong, okay? I can say that the work done by me got stored as potential energy, or I can say that when the object went from point A to point B, the work done by gravity, right, which is negative work done, right, that is my potential energy, and when the object goes back, then gravity is doing positive work. So once again, so let's say this is Earth, right? The object goes from here to here, Earth is pulling it back, so now Earth is doing negative, the gravity is doing negative work, and when it comes back, gravity is doing positive work. Once again, when it goes up, gravity does negative work, and when it's coming down, gravity does positive work. So I can also say that the negative of work done by gravity, that is equal to your potential energy. Okay? So now this is very interesting, that so one observation now I'm going to make is that when the object goes from here to here, right, the work done by gravity, let's say the work done from here to here, work done by gravity was minus W, right? When it goes from here to here, work done by gravity was minus W, and when it comes back, work done by gravity is going to be plus W, which means what is the total work done? Slowly, object goes from here to here, what is the total? So gravity is pulling it down, and then it comes down again, gravity is pulling it down, right? So initially work done is negative, then positive. Total work done by gravity, when it goes from here to here, right? So we'll say point number 4, from A to B to A, right? Total work done total by gravity, right? Gravity, this is equal to minus W plus W, this is equal to 0. Right? Now we are observing that in case of gravity, right? I'm not talking about all forces. In case of gravity, the total work done is 0, and I showed for only one path, right? But we can show it for any path. So as an example, instead of going like this, if this object was taken, let us say, through a path like this also, right? The same, and then it goes like this and it comes back like this, right? It doesn't matter what the path is, as long as it goes and comes back to the same point, the work done, total work done by force of gravity is going to be 0, and such a force, right? Such a force is called a conservative force. Such a force is called conservative force. What is a conservative force? Conservative force is a force where work done, right? Work done for closed loop, right? Closed loop, this is equal to 0. Since the total work done is 0, which means, think about this carefully, the total work done is 0, which means the work done, the negative work done and positive work done, they'll always have to be, if they go from point A to point B, they'll have to be equal, right? And therefore, only in these cases, since the total work done is 0, if some work is done by external force, we'll get it back, right? And such a force, and such a force we call conservative force, and only for such a force we define potential energy. Because remember, for potential energy, what is the idea? You do something, you get it back. So it's like a bank. I put 1,000 rupees in a bank, and then next time when I go, I can get 1,000 rupees back. But if you put 1,000 rupees, and then next time you go, they give you like 500, right? You'll say, no, like this was not stored, it was taken away, right? So it is not, so we'll not call it potential energy. So point number 5 is, we define potential energy only for conservative forces, only for conservative forces, right? Forces, okay? So only for conservative forces we can define potential energy, and now I'll summarize this for you, okay? And this we did for gravity, but this will be true for a conservative force in general. So let's start the argument again, just to quickly recap. When object goes from point A to point B, some work is done by an external force, right? There is no change in kinetic energy. We are moving it in such a fashion. In that case, work done by me is going to be negative of work done by the force of gravity. Since total work done is, and we know total work done is 0 because change in kinetic energy is 0. Next point is, when I do the work, right, when the object comes back, we get it back. We get it back as kinetic energy, right? And therefore I can say that since you're getting it back, I can say it is stored because I'm getting it back. You know, it's like a bank which gives you back $1,000 when you put in $1,000 there, right? So I can say it's stored, and I give it a name. I call it potential energy. In this case, I call it gravitational potential energy. And next point is, because it's since it's stored and I have this name, question is how much is the potential energy? So it is equal to the work done, and which is equal to the negative of the work done by force of gravity, or in other cases it will be whatever is the force field that we are talking about. Here we're talking about gravity, right? And finally we said that because the total whatever work is done is negative and positive, right? The total work done is going to be 0 if the object comes back to the same position. And I said that for any path that will be the same that will be true, and such a force is called a conservative force. And only for conservative forces we can define potential energy, because potential energy is a stored energy, so we should get it back, right? So if it's not conservative, we'll not get it back. We'll not get back fully, right? So therefore the term potential energy has a meaning only for conservative forces, and so P is this term has a meaning only for conservative forces, right? And therefore now in summary, for a conservative force, right, the potential energy is the work done by an external force to take the object from point A to point B, right? Or it is a negative of the work done by the negative work done by the force field, right? One last thing, and then I'll close this lecture, right? Now let's say you took an object from here to here, right? So we said the work done here is the potential energy, right? But somebody say, why this point? What if somebody takes the object from here to here? Then what happens? Like, is it the work done from here to here, here to here? So now we'll say that potential energy is the work done from a given point, and this point is arbitrary. So I have to pick one point. So I can say, so somebody says, what's the potential energy of the object here? So we'll say, if I take this as my reference point, I'll say this point carefully. If I take this as my reference point, think of a starting point, right? So I'm measuring everything from this particular point, right? Just like, I'll give an analogy. Let's say somebody says, where is this hotel? So you'll say, yeah, that hotel is, say, 2 kilometers from this particular point, or you can say it's 1 kilometer from the next traffic junction. So you're taking a starting point. So similarly, when we talk about the work done is always over a path from point A to point B. So where is point A? So point A can be any point, and we call it the reference point. So now the last point is the potential energy, right? This is 5, so I'll say point number 6. The potential energy is the work done by external force from a reference point, right, to the given point. And the work done when it goes from external, when it goes from a reference point to given point, right? Reference point, this PT is point, right? This is a separate word. I'll write it carefully, reference point, right, to the given point, okay? And it has to be taken in such a way that the kinetic energy does not change, right? Because if K changes, I can do any amount of work, right? So work done, just the amount of work done to move it without change in potential energy, without delta Ke, right? Without change in kinetic energy, the work done, this is equal to potential energy, and this is also equal to negative of Pe is equal to negative of work done by gravity in this case, but could be any other force field, right? So this is the concept. Please go through it very, very carefully. If needed, replay this video once or twice again, but get this right, because this is the foundation. Thank you.